Okay, we've got a probability question. We've got some information about studying maths and English, and we're encouraged to put it into a two-way table, which when you can do it is a great simple way of organising data for probability. So we've got 50 students, so that's the overall total. 50 students is what everything adds up to. And we know that 30 students study maths, so that's the total for maths is 30. And we know that 25 study English, so the total for English is 25. And we've got 10 students who are studying both maths and English, so that's 10 here. Okay, so this is the total number of studying maths down here, so there must be 20 studying maths but not English. And the total studying English is 25, leaving 15 that study English and not maths. And if there are 25 English students and 50 altogether, there must be 25 not English students. And if there are 20 students in this category, but the total number not studying English is 25, that only leaves 5 down here. That gives me a total of 20 not studying maths, and the check is that 30 plus 20 is 50. So now I have all the things I could possibly want. So what did I have to find out? I have to find out the probability a student chosen at random is studying maths or English. Okay, well, maths or English means they may be studying maths, so they could be any one of these, but they may also be studying English or both, so they could be any one of these in the loops. Okay, I mustn't count these 10 twice, so I've got to do 20 plus 10 plus 15 is the total number of students who either study maths or English or possibly both. And the total number of students altogether is 50, so the probability of studying maths or English or both is 45 over 50, but I should cancel that down to 9/10, or decimals is fine, 0.9. Okay. Now the other way of doing this is to use the formula higher up the page, which is the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So in this particular case, the probability of studying A, if A is maths, the probability of studying maths is 30 over 50. Okay, don't need the P anymore because I've put in the correct probability. Plus the probability of studying English, well, that's 25 students out of 50. And I've got to take away the probability of studying maths and English, but that's 10 out of 50. So I'm going to do 55 over 50 minus 10 over 50 is 45 over 50 again, which once again is 0.9. Okay, and if you look at the way this has worked, okay, if I add up this 30 and this 25, which is what's going on here, I'm counting the 10 twice. So the job of this bit here is to take away the 10. So that, in fact, is why this rule should make a lot of sense. Okay, so I would suggest if you can draw the table, then draw it, but don't forget the rule exists. Okay, it's not in your formula books, you have to learn it.